name is Michael Keegan, and I'm the chairperson of the Coalition for Nuclear Free Great Lakes. And how that came about was we had a big gathering like this in September of 1986, and we had quite a bit of media turnout. About 18 different media folks came out. We had a sizable crowd. And I left the room for a moment, and Dr. Mary Sinclair, Channel 7 came up to Mary and said, well, who's the chair of this organization? And Mary said, Michael Keegan is on the hall. So the first I learned about being the chair of the organization was when Channel 7 News informed me of such. So here we are 25 years later. And it's Coalition for a Nuclear Free Great Lakes. It's like mom and apple pie. I mean, does anybody want nukes, radiation in their water in the lakes, 20% of the world's surface fresh water? No. So it's an admirable. And I think even nuclear industry people would agree they want a nuclear-free Great Lakes. But we realize that there's threats that are ringing the Great Lakes. That's why we're here, because we, as challenge response, all of history is challenge response. We have a challenge before us. And contingent upon how we respond is whether or not we're going to survive as a species or any species. I mean, we're on the verge of omnicide worldwide. The atom has subverted science. It has systematically undermined science because the pursuit, the ultimate pursuit, the genesis was we need a coercive tool that we can threaten people with. And so that was the pursuit of the bomb. And the nuclear energy was necessary to get the material for the bomb. A little bit later, in 2 months' time, there's going to be a major conference over in Chicago on the 70th anniversary of the Fermi pile. Now, the Fermi pile was in Chicago field. It's when the first fissioning took place, and that's what produced, I believe, the first material for weaponry. So 70 years of nuclear waste piling up. So please come to Chicago. We can change the world. So we will do that. You gotta wait till December. I know you're anxious for that. But the atom has subverted science, and we're here to claim it back. And we're here to bring in and do the analytical thing and bring all life-sustaining. Where's the biology? Where's the health issues? Where are the political ramifications, the economic? I mean, they're dipping into our pockets to fund these exorbitantly priced plants. So we're here to reclaim that. And so we're about prevention. Fukushima, and many of us know that is far from over. That's going to be decades. That's potentially 100 years. That's potentially 100,000 years. And it's potentially could get about 80 to 100 times worse than what it is right now. So we're about prevention. And borrowing from Albert Einstein, he suggested we take it to the village square because the atom has changed everything except the way we think. But it was, the genesis of the atom was in secrecy, and so we were locked out of it because it's been nuclear scientists, nuclear physicists, engineers. It's been very technical, very patriarchal, male-dominated. And today there's probably a pretty heavy male presentation and maybe underrepresentation by women. But we're trying to do some kind of a balance because that's what we need to sustain life. That's water is essential to life, air and water, and yet we're jeopardizing it all. One mistake, we could lose the lakes. I think you'll hear that a little bit later in the song by Victor. But I'm trained as a social scientist. And so we need to reclaim the science. And we need to get people, the social sciences, brought into the equation. The political science, history, biology, all these different various sciences have been excluded from the equation. So we're knocking on the door, and we want in, and we want to change things.
Little ways down the bay from Tachinga Bay, along the northern shores of Great Lake, Michigan. A place called Big Rock Point became an early atomic joint out of the two G Near sacred dancing ground where a doll once lived free, and the whitefish shine silver in the bay. And the white pine grew so tall you could hear the eagle call. Life was good and pleasant, the old ones say. And some strangers came along, something went wrong. Soon the peace was shattered and all the big trees fell. A way of life nearly rubbed out for the sake of money and freedom, no doubt. And this land between the lakes became living hell. Big rock points on the line. See the shiny uranium fuel rods blow, hear steel steam turbines whine. They're risking future generations for little electricity. A nuke reactor for every nation quickly becoming a reality. Oh, by the way, please don't forget, the plutonium is free. Now the big rock points on the line. Dear sacred dancing ground where a doll once lived free. I'm sorry. Sometimes this song stirs something inside. Near sacred dancing ground where a doll once lived free, and the life. This is really hard for me right now. I'm sorry, guys. I'm missing some elders, that's all. Near sacred dancing ground where a doll once lived free, and the whitefish shine silver in the bay. When the white pine grew so tall, you could hear the eagle call. Life was good and pleasant, the old ones say. Then white strangers came along, something went wrong. Soon the peace was shattered, all the big trees fell. A way of life nearly rubbed out for the sake of money and freedom, no doubt. And this land between the lakes became living hell. Big rock points on the line. See the shiny uranium fuel rods blow, hear steel steam turbines whine. They're risking future generations for little electricity. Well, now it has become much more than just apparently that the multinational conglomerate corporate capital monopoly don't seem to give a damn about future life, much less about you and me. Better get big rock point on the line.
Thanks a lot for coming out. My name is Gordon Edwards. I'm from Montreal. I'm a physicist and mathematician. I'm a retired mathematics teacher. Originally, I graduated with a gold medal in mathematics and physics from the University of Toronto. Although this workshop was entitled Newspeak in the Great Lakes, I've been asked to discuss the military origins of Canada's nuclear program, which of course coincides with military origins of the U.S. nuclear program. But I would like to say a few words about Newspeak itself. That is, the peculiar vocabulary that's used by the nuclear power industry to deflect and to mystify, to deflect attention and to mystify people as to the true nature of what we're dealing with. When I grew up, 1984 was in the future. And in 1984, George Orwell, he wrote this novel in 1948 and just transposed the last 2 digits to make it 1984. And in his imaginary future, he had, one of the most amazing things was his discussion of language. And they had a language called Newspeak. And Newspeak was a language where it was literally impossible to think a thought that was opposed to the state. And so Newspeak was really an invention of George Orwell. And he had 4 ministries in his dystopia of the future. The Ministry of Peace, which dealt with war. The Ministry of Truth, which dealt with propaganda and lies. The Ministry of Love, which dealt with torture. And the Ministry of Plenty, which dealt with scarcity and deprivation. And You know, the USA in the 1940s, they had a Department of War. Now they call it the Department of Defense. So we have adopted a lot of the ideas of George Orwell, which he was not advocating, but was warning us about. And the nuclear industry has also been very, very good at coining words that really prevent us from even thinking about what we're talking about. For example, the nuclear industry, in the days when we first had contaminated communities in Canada coming to attention, they didn't talk about the acceptable dose of radiation, they talked about the recommended dose. They said, oh, this is way below the recommended dose of radiation, as if, you know, if you didn't have your recommended dose, you were really missing out. In fact, I'm going to be talking about Port Hope, Ontario, and when that town was found to be contaminated, they had to evacuate an elementary school because the levels of radiation in the cafeteria were higher than those allowed in the uranium mines. And they had to destroy about 100 homes and buildings which were contaminated by radioactive material, which had been given freely to the workers as a bonus that they could use for landfill and for construction. This is radioactive radon-generating materials, and it was known to be dangerous at the time. I mean, it cannot be said that they didn't know this stuff was dangerous. And yet they called it a recommended dose. They no longer use that phrase, but they very often still talk about a safe dose. These doses are not safe. You know, all the scientific evidence we have indicates that there's no evidence for any safe dose of any cancer-causing agent, by the way, not just radiation. For example, asbestos. There's no scientific evidence whatsoever that there's such a thing as a safe dose for carcinogens. And in fact, all the evidence points in the opposite direction, that there is no safe dose, but that if you have a large population of people exposed to even a low level, you will see an increase in cancers. You just won't see as many cancers as if the dose were higher. But to call this a safe dose is a perversion of the truth, and is designed to misinform and to mystify and to mislead. Even calling it a permissible dose is misleading, in my opinion, because who is doing the permitting? And it's the industry that considers it a permissible dose because they need to expose people to atomic radiation or ionizing radiation. And so they need to permit a certain exposure, certainly to their workers, and by extension to the community. Another example is calling the irradiated fuel, which is so radioactive that it would kill any human being standing 1 meter away from it in about 20 seconds. To call this spent fuel, you know, as if it's exhausted and can hardly blow its own nose, and yet it's millions of times more radioactive than the fresh fuel. The fresh fuel that goes into the reactor can be handled relatively easily without elaborate equipment. The so-called spent fuel will never be handled by human hands again. It's only handled by robots because it's so, it gives such a blast of penetrating radiation that will kill people at a distance, unlike the fresh fuel. Talking about disposal, as if we know what that means. As I often point out, there is no scientific definition even of the word disposal. You cannot define what it means, because all it has to do with is our intention to abandon it. So instead of disposal, it should be called advanced dumping. You know, we're just dumping the stuff. Dumping it means you put it somewhere and you just sort of back away, and then you turn away and you run away, and you abandon it. That's basically what they are calling disposal. We don't know how to dispose of anything. The human race, in fact, has never disposed of anything. Unless we know how to destroy it. Or if we had Star Trek technology and we could beam it into the sun without the necessity of using rockets that will explode as they go up, you know, if we had such a technology, perhaps we could talk about disposal, but we have no technology for disposal. Recycling, they talk about recycling, and you've all been hearing more of this probably, about recycling the waste. The waste from nuclear reactors is actually can be recycled. When they talk about recycling, they mean robotically chopping up this highly dangerous material, releasing radioactive gases in the process, dissolving it in boiling nitric acid, creating hundreds of millions of gallons of radioactive liquid waste, and then separating out about 1% of that material, which is called plutonium, and then using that, and then being left with this large volume of liquid waste, which has to be re-solidified and is still intensely radioactive and still needs permanent storage forever, and they call that recycling. I mean, this is not recycling. This is really opening a Pandora's box of problems, as we had at West Valley, just here on Lake Erie. We had a private commercial company that was going to be reprocessing or recycling commercial fuel, and it just resulted in a multi-billion-dollar mess, along with radioactive contamination and other of the environment and of part of Lake Ontario. Even the sediment in Lake Ontario has plutonium contamination from that plant. So I can't go through this whole vocabulary, but I would urge everybody to not to use the words the nuclear industry uses, but to adopt a different vocabulary. Do not fall into the trap of using their language, because this language is not intended to clarify. This language is intended to obscure. We talk about reactor safety instead of reactor hazards. We talk about the nuclear fuel cycle when the most obvious thing about it is it's not a cycle. We call it now the nuclear fuel chain, a much better word to describe it. Radioactive decay, you think of decay as being a natural process which is gradual and which returns everything to the earth. You know, decay produces fertilizer for plants and animals and so on. Well, radioactive decay is just not like that. It's a sudden, violent explosion of atoms, which they, again, use the word disintegration for, suggesting a kind of a gradualness which isn't really part of radioactivity. Radioactivity is a sudden, violent process where atoms explode, and if those atoms happen to be inside your body or in your vicinity, they can damage your cells. And it's at the moment of explosion that they're dangerous, not at any other time. So if a radioactive material goes through your body and doesn't happen to explode while it's in your body, then you have not suffered the radioactive ill consequences of that. But of course, if there's enough of that material, there will be many explosions going on. They often also say, well, there's no immediate danger, which is the ironic title of the famous book by Rosalie Bertell, dearly departed. She died just this past year. She was a very wonderful person. At any rate, no immediate danger, of course, refers to the fact that at low levels of exposure, unless you're exposed to very high levels of radiation, which make your hair fall out and your skin turn red and possibly make you feel nauseous and get very sick indeed, which is radiation sickness, and then possibly die or recover. Unless you get very high doses of radiation, the consequences are not felt for years. In many cases, the worst consequences, for example, cancers, leukemias, or genetically defective children or grandchildren, these consequences often come decades after exposure. So to say no immediate danger is really so misleading. It just means that, well, you may die from this, but not tomorrow. You know, and you look at the Japanese, it's too early to see the cancers that are going to result from that. But if you look at the evidence about uranium miners, they find that it takes about 20 years after exposure before you begin to see a marked increase in lung cancer among these miners. But once that begins, after 20 years, it continues year after year. The British Columbia Medical Association describes it as a gradually flowering crop of radiation-induced cancers. And so there's no immediate danger to any of them. The danger is when they thought they got away scot-free. That's when the danger is. Now, about the origins of the nuclear industry. The nuclear program began when a little-known element called uranium was discovered to have a remarkable property that it shares with no other naturally occurring element. This is a model of the uranium atom. It was discovered about 200 years ago, but there wasn't any practical use for it. until they discovered in 1938 that you could release an enormous amount of energy by cracking the nucleus apart using a little projectile called a neutron. And uranium is the key element of all nuclear technology, both military and civilian, because it's the only radioactive element or any kind of element from which you can get large amounts of usable energy directly from the nucleus. And this is done by splitting the uranium atom. This is a monument in Russia to the splitting of the atom. It shows the uranium atom, or it symbolizes the uranium atom at the very moment of being split. And those semicircles around the broken pieces of the uranium atom indicate the energy that's released, which is about 400 times greater than the energy from the most violent chemical reaction you could imagine. So think about the most violent chemical explosion you've ever seen, and then multiply that by 400, and that's how much you get from the splitting of a uranium atom. The man in the foreground here is Kurchatov. He was the father of the Soviet atomic bomb. These pictures were taken by a colleague and friend of mine, Robert Deltredici. So this, now, what we have here in 1943 is how Canada and the United States really got into the nuclear program at a governmental level. This meeting is in Quebec City. At the very extreme right, we have Winston Churchill. In the middle, we have President Roosevelt. And at the extreme left, we have the then Prime Minister of Canada, Mackenzie King. And they were signing something called the Quebec Accord. And this was an agreement by which they would agree to cooperate in developing the world's first atomic bombs using this fission process. The reason why Canada was involved is because we had uranium. And therefore, we had the only source of supply that could be used to start this project going, which in America came to be known as the Manhattan Project. In Britain, it was known as the Two Alloys Project. The first two bombs that were built were, the first two bombs that were used, rather, were the one in the foreground is a model that's called Little Boy, and it was made from highly enriched uranium from Canada. And the second one in the background is called Fat Man. It was dropped on Nagasaki 3 days after the Hiroshima bomb. And it was made from plutonium. And plutonium was created inside nuclear reactors which were built in Washington State using Canadian uranium and also uranium from the Congo. And what happens in a nuclear reactor is that these uranium atoms, some of them split and produce a lot of energy, but others are transformed into plutonium. And plutonium turns out to be a very good nuclear explosive, more powerful than uranium-235. So plutonium has become the nuclear explosive of choice around the world. When they talk about, this is a melted statue of Buddha in Hiroshima that was melted instantaneously by just the burst of the Hiroshima bomb. These photographs are all taken by Bob, my friend. Here's a guy who developed nuclear weapons. His job was to design these nuclear weapons. And when a bomb explodes, not only do you get this enormous energy release and a fireball, but you also get a scattering of the broken pieces of the uranium atoms that have been split. And these broken pieces are called the fission products, or fission fragments. And they are hundreds of unstable chemical elements. Unstable in this case means radioactive. And these intensely radioactive chemical elements are dispersed as pollutants into the environment. And depending upon how radioactive they are, what the half-life is, they will last for a long time or for a shorter time or for a very long time. So for example, some of these materials will be gone in a few years because they disintegrate so rapidly, the atoms explode so quickly that there are virtually none left after a few years. Such is the case with iodine-131, one of these products. Others will last for hundreds of years. For example, cesium-137, which has a half-life of around 30 years. What that means is that half of the atoms will explode in 30 years, over a 30-year interval. But there's still half left. And so they will continue, half of what remains will explode over the next 30 years. And you'll still have a quarter left. And then half again will explode over the next 30 years, and 1/8 will remain. And so it goes. And so it takes at least 300 to 600 years before the cesium-137 will be gone. It's going to be a problem for centuries. You have other elements like plutonium itself, not all of which gets used. Some of it just gets blasted into the environment. And that has a 24,000-year half-life. So you can imagine that's just basically, as Helen Caldicott said, plutonium is thalidomide forever. Now, in Canada, we really got into the uranium business in a big way, not only during World War II as partner to supply uranium for the first bombs, but after World War II to supply the buildup of nuclear weapons, tens of thousands of nuclear weapons. And so we became, and have always been, one of the world's largest producers and exporters of uranium. And we call this the Yellow Cake Road. This is a map that Bob and I made together on my Macintosh. And it just shows the mines in Canada that are all linked by a pathway down to the Great Lakes to a community just east of Toronto called Port Hope, Ontario. And Port Hope, that's where they found all these contaminated buildings. Port Hope is where they originally processed, before World War II, they processed radium for medical purposes and for other frivolous purposes. And during World War II and afterwards, they processed it for uranium. So that's how Canada really got involved in the nuclear program. Now, even though bombs evolved into more powerful weapons called H-bombs, intercontinental ballistic missiles and so on, nevertheless, even the H-bombs, which depend upon nuclear fusion, they still require plutonium. You see that ball at the top there? That black ball? Well, that's plutonium, and that's a model of the H-bomb. This is Howard Moreland on the steps of the Supreme Court of the United States after winning his case. Because he published an article called How to Make an H-Bomb, and he was accused of treason. But he won his case because he found that most of these information had come from the Encyclopedia Americana, written by a fellow named, father of the H-bomb, Edward Teller. In both Canada and the United States, the first reactors that were built not to produce electricity, but to produce plutonium. This is a plaque at Chalk River in Ontario, where Canada's first nuclear reactor was built as a result of a wartime decision made in Washington, D.C. in 1944. And the plaque says that the purpose of this reactor was to produce plutonium for nuclear weapons. So, you see, that's why these reactors were built in the first place. Plutonium has a 24,000-year half-life, so as you produce the plutonium, you can just stockpile it and use it when convenient. Somebody got the idea along the line, well, since we're producing plutonium anyway, and since producing plutonium involves all this energy and all this heat, why don't we produce electricity as a byproduct? And in fact, that's what reactors really do. They produce plutonium, which lasts forever, and they produce a byproduct, which is called electricity. And so they can sell the byproduct, and after about 20 or 30 years, or maybe 50 years if you're really lucky, you've had your dose of electricity. You're not going to get any more electricity from this plant, but the plutonium is there forever. And anybody can go back and retrieve that plutonium and use it to make bombs at any time in the future. So we are creating stockpiles of plutonium around the world. That's what's really happening with these nuclear reactors. The ultimate product of a nuclear reactor is high-level radioactive waste, which remains dangerous for millions of years, and plutonium, which remains a potential weapons material for tens and hundreds of thousands of years. And we get a few decades of electricity as the benefit of that. This is how plutonium is created inside the reactors. There's a certain type of uranium, the most abundant type, called uranium-238. It's more than 99% of natural uranium. And when it's hit with a neutron, the very particle that causes the splitting of the other type of uranium, it doesn't split. Instead, it turns into plutonium. So plutonium is created this way. It's called a transuranic element because it goes beyond uranium, which is the heaviest last element in the periodic table of elements, of naturally occurring elements. Now, that's how much plutonium you need to destroy a city. This is a glass paperweight that was deliberately manufactured to have exactly the same size and shape as the ball of plutonium in the Nagasaki bomb, and weighs about 6 kilograms. Each reactor, a large power reactor, such as the Fermi 2 reactor, for instance, or the Perry reactor, I'm not sure what the megawatts of Perry is, but a large power reactor will produce enough plutonium every year to make several dozen, maybe even as many as 100 nuclear bombs. And just multiply that by the number of years, and then multiply that by hundreds of thousands of years into the future, and you'll see what kind of a legacy we are leaving for our distant descendants. In order to get the plutonium out, this is at Hanford, Washington. In order to get the plutonium out, you're faced with a difficulty, and that is, remember I told you that the irradiated nuclear fuel is so radioactive that it will kill any person within 20 seconds to just be a meter away from it. So the question is, how do you get the plutonium out of that? It has to be done with difficulty using a robotic plant which chops it up and dissolves it in acid and then separates out the plutonium. And this is what's left behind. These tanks are designed to hold the high-level radioactive liquid waste at Hanford, Washington from plutonium separation operations. And those tanks have paddles inside to constantly stir it, because if they don't stir it, it will overheat and possibly explode. That happened in Russia in 1957 and caused a huge disaster. So I'm going to wind up now. I just want to wind up by saying this. Around the Great Lakes, we have several facilities which you should be aware of. One of them is Port Hope, Ontario, where there are hundreds of tons of radioactive waste which have been dumped into the harbor right beside Lake Ontario, and which continues to pollute Lake Ontario from uranium processing. Up the Ottawa River, there's the Chalk River establishment where they did reprocessing at one point and where you have leakage into the Great Lakes. Just at the end of Lake Erie, you have the West Valley plant, which has left a legacy of liquid waste and plutonium contamination and so on. And these are these are facilities which are going to threaten the Great Lakes for a long time to come. Thank you.
I'm Diane DeRigo. I'm Radioactive Waste Project Director at Nuclear Information and Resource Service. My background is in chemistry and environmental studies. I'm from Buffalo, New York. I was pulled into this issue when I went to college. I wanted to learn environmental issues in chemistry to learn how to clean up the environment and to prevent contamination, only to find out that there were no jobs for that effort. You could get hired to stamp papers that allowed chemicals to be released into the Niagara River. Those kind of jobs were available, but not to actually review and not stamp them. You could get a job allowing chemicals to be buried in certain pits, unlined trenches in ground, but preventing the production of those has become all of our struggle, I believe, here in this movement, is to prevent creating materials that can't be contained forever. I'm supposed to be talking about the history of the nuclear industry on the U.S. side of the Great Lakes, and I'll sort of address that from the perspective that I have known and worked on in my years. I think most of us know historically that uranium was first discovered in the 1800s. And actually, I don't know that, I think that's true. People were mining it and becoming ill. And then the first chain reaction, sustained chain reaction, was in 1942, 70 years ago, December. And when they realized that the reaction could occur, it took a major effort. The reason we have such a huge nuclear weapons complex, we've got about a dozen or so major Department of Energy weapons sites that were rapidly built during World War II to harness, to concentrate, needed to put so much energy in to get the uranium to a condition that it could be used to make weapons and then eventually power, that the Germans didn't really think that we would be able to do it. They were trying to do it, but the fact that we had made it a major national priority to build this complex, huge areas of numerous parts of the country were sacrificed, were just condemned and made into atomic villages in Washington, in Oak Ridge, Tennessee. So the Great Lakes is a place where there was a lot of energy, electricity, and a lot of water. So the industry, not just the nuclear industry, but the industry, of course, concentrates here around the Great Lakes. And the nuclear industry then, when they were in their rush to manufacture the nuclear bomb, took advantage of where the industry was. And there are many steel facilities and other industries where we are told that the workers didn't even know that they were working with radioactive materials in this secret bomb complex. So we had many nuclear sites, many sites that are contaminated with radioactivity that some people didn't even know existed when they were in operation. So this would not be those big weapons complexes, but these are steel industry facilities around the Great Lakes. So the steel industry helped to build the nuclear power plants and the nuclear industry that built. As I'm mixing here because this is what was happening. We had the weapons complex, but then also the beginning of the power complex. And I've counted them up. We've got about 25 nuclear power plants on our side of the U.S. side of the Great Lakes, and many other nuclear supporting industries. And we've got, as I'm saying, the metal industry, which it's, the relationship is interesting. One is that the steel industry helped to build the nuclear industry, and both are polluting industries. However, the steel industry is now being threatened with taking the refuse of the nuclear industry and it being incorporated into the steel supply, because the steel industry internationally is the best recycler that we have in the world. They are the best at recycling steel. And so now the nuclear industry, as they dismantle enormous complexes around, and refurbish them around the world, are taking their radioactive metal, and Gordon last night described how materials can become activated. In the core of a nuclear reactor, the metal that goes in to build those components is not radioactive. But with bombardment by neutrons over the years, radioactive elements do form in that steel. So we've got nickel-59, niobium-94, which have half-lives of 20,000 and 80,000 years. So multiply by 10 or 20 for hazardous life. Embedded in the metal, volumetrically contaminated metals. And then we've got metal throughout the complex that gets contaminated on the surface from the radioactive materials that are within the facilities. And for some reason, the nuclear industry likes to make a distinction between volumetric and surface contaminated metal. But the upshot is that a lot of metal is getting contaminated by the nuclear power and weapons complex. And so the big event, the big visible manifestation of this is that the steam generators, the radioactive components from the Bruce nuclear power stations up in Canada, the plan for that was originally to store it and treat it as waste, but then OPG that decided to, Bruce Power, decided that they would try to send this metal. Huge steam generators are the part of the nuclear reactor that, they're big components of the reactors, and many teeny tiny tubes, radioactive materials, radioactive water circulating, and so they're contaminated on the surface, but many surfaces. So the plan was to send these steam generators the size of school bus. In the U.S., our steam generators are a 2-story building size thing, but to send them on ships to Sweden, through the Great Lakes, across the Atlantic, through the strait between Denmark and Norway, and up into Sweden, where they would, Studsvik is a company, one of the few, but growingly important nuclear processors that take nuclear waste and do things to it to allow it to be released into the marketplace or to regular garbage. So what they're doing in Studsvik in Sweden, and it's in Sweden only because we've stopped them in the US, but that could change. Studsvik takes radioactive components of reactors and melts them down, claims to separate the radioactivity out, and then take the so-called clean metal and release that into the metal market. And so this has been stopped in the US, releasing radioactive materials into the marketplace, but in Sweden, they do it. And the European Union in 2004 set allowable legal levels for radioactive contamination, release levels. We do not have those in the United States. Canada snuck them in, and part of our campaign is going to be to overturn that. So the people concerned about nuclear shipments in the Great Lakes were able to stop, so far, those shipments because of the dangers of having contaminated radioactive material transported on the Great Lakes. It's actually highly contaminated with plutonium and met some requirements that the transportation regulations triggered, which required US approval, which required some notification. Of course, the international transportation regulations, the international transportation recommendations have been changed. And so the US and Canada are in the process of changing their transport regs so that that would not be triggered, so that these shipments could go without any notification or approvals. So there's that way that the rules are changed to facilitate whatever the industry wants to do. Allowing radioactive materials to be released into everyday consumer goods via the Studsvik processor. We have processors in Tennessee, quite a number, and now we have a new one in Ohio, which we'll talk about in the waste session coming up at the end of the day today. New Green, right next to the Perry plant on Lake Erie, that doesn't do the melting, but it does do other types of processing of radioactive materials. So I thought what I would do as part of the history of the U.S. nuclear industry would be this little piece of history on how they're getting away with, or trying to get away with, releasing, dispersing the radioactivity from the nuclear power and weapons complex. In 1970, the Environmental Protection Agency was formed, and the EPA's job is to protect the public from radioactivity, except on Nuclear Regulatory Commission sites. So the Nuclear Regulatory Commission and the EPA have responsibility for protecting us from radioactivity. And in my years, I started at NEARS in '86, so it was around then that I know of the EPA, the NRC, trying to deregulate or allow what was previously regulated radioactive material to be deregulated into consumer goods, into the marketplace, and into landfills. So public organizing, many people in this room over and over have helped to stop those agencies from allowing the stuff to be released. But there's still that effort. As long as they have the waste, and they don't want to pay a lot to try to isolate it forever and ever, they're going to try to release it. And there are many clever tricks. The Atomic Energy Commission was formed back in the 40s, and in 1974 split into the Department of Energy and what is now the Nuclear Regulatory Commission, one to promote nuclear technology, one to supposedly regulate it. And in 1980, the Low Level Radioactive Waste Policy Act passed Congress. In '85, the Amendments Act passed, and there's a Section 10 of that which directed, this is Congress now, didn't know what they were doing, or maybe they did, directed the Nuclear Regulatory Commission to set a below regulatory concern level, a level below which they don't have to regulate. So the EPA at that time estimated that the level that NRC was trying to deregulate would have allowed for a quarter of the radioactive waste from nuclear power industry to be transformed from radioactive waste to not radioactive waste. So this was a big fight that many of us waged. About 15, 16 states passed laws requiring that waste continue to be regulated. And Congress in 1992 actually overturned the nuclear regulatory policies that would have allowed this below regulatory concern. Meanwhile, internationally, the International Atomic Energy Agency was setting levels for clearance, release, and exemption from radioactive controls, and were able in 2004 to get Europe, the European Union, to pick a clearance level, which is why Studsvik is able to directly release into the marketplace. This is an effort that we are still winning on. We do have victories, and this is one of them. However, the NRC, the EPA, the Department of Energy, over the decades, have been trying over and over again to find different ways to allow their waste to be released and deregulated. In the year 2000, when Clinton was president and Richardson was DOE secretary, there was a ban placed on, it was a moratorium and a suspension on the release of volumetric and surfacely radioactive contaminated metals. Any metal from DOE, Department of Energy, weapons complex sites could not go into commercial recycling, metal recycling. And Secretary Chu last year signed an order saying that they're going to reverse those moratoriums and suspensions to allow the stuff. So we will have, probably after the election, the opportunity for probably 30 days to comment on a plan whereby the Department of Energy will release radioactive materials into the marketplace. And the motivation for this is from nuclear facilities that are trying to clean up, quote unquote, clean up and clear out. So I think we can win on preventing that reversal if we make a campaign. And I think the campaign can be linked to the international opposition to metal being recycled, released into commerce, radioactive metal being released and recycled into commerce. The metal industry is opposed to being the waste pit for the nuclear power industry, even though they are allied in many ways. The metal steel manufacturers in the U.S. anyway have a zero tolerance and zero acceptance for radioactive contamination. This is not so in Canada, but and it's also very difficult to enforce. One more minute to describe this. Each agency, EPA, Nuclear Regulatory Commission, Department of Transportation, Department of Energy, were in their own ways all trying to help the industry to release the materials. And we've been going after them, campaign, stop. Now this DOE one is the latest manifestation in the US of it. But the larger question of allowing a release, the agencies were having a hard time figuring out how to release this stuff, how to get away with it when we knew about it. So the National Academy of Sciences was called in, the U.S. National Academy of Sciences, to review the Nuclear Regulatory Commission's efforts, and they tried to, they criticized the Nuclear Regulatory Commission for being not really good at getting away with this, not involving the public. But they recommended that instead of taking it on head-on, that they should, case by case, release this stuff into landfills, incinerators, recyclers, and it would be up to those facilities to keep it out. And what I want to say to conclude is that there are waste sites in the Great Lakes to which they're regular garbage dumps, industrial landfills, and these have been places where nuclear waste from decommissioning, for example, Big Rock Point was decommissioned, dumped a lot of its waste at the Waters landfill, so regular garbage dump, industrial. And when they were cleaning up Maine Yankee, decommissioned the Maine Yankee reactor, some of that waste went to landfills in Niagara County, along the Niagara River. And same thing for the Department of Energy complex in New Mexico. They clean up some of their waste, they end up dumping it, trucking it all the way up to the Great Lakes to dump because they claim our background is higher and therefore they can get more radioactivity into our dumps. So what we've got is a campaign in the development stages that I hope we will all be part of.
It's about reclaiming claiming our history and who's going to control history and who's going to tell the story. And there's so many dimensions to history and so many perspectives, but what makes it into the official history books is often skewed. Of course, we set off on the pursuit of the military of the bomb. In 1942, the Chicago pile was the first reactor that was produced plutonium. So we had a bomb test in Trinity, Alamogordo in July of 1945. And at that time, the physicists, nuclear engineers were concerned that potentially we just may set the atmosphere on fire. They were actually taking bets on it, whether it would occur or not. 3 weeks later, the bomb was dropped. Nagasaki, Hiroshima, August 6th and August 9th. But by the time the bomb had been produced, manufactured, 600,000 people had worked on the project. Universities, labs, Dow Chemical, DuPont, GE, Westinghouse, all these mega corporations were all involved. Universities, U of M was heavily involved, a number of universities. 600,000 people. And having read all of Max Weber, a famous sociologist who knows about bureaucracy, the first rule of bureaucracy is to self-perpetuate. So now we have all these universities and everybody, it's a nice income stream, let's just keep pursuing it. We were fighting fascism, this is what it was built for. Ironically, it was not dropped on Germany. And the reason I had to sit across from here to there, just 10 feet away from a Congressman, John Dingell, tell me how the dropping of the bomb saved his life and saved 1 million American lives by not having to go and invade Japan. And this is a very highly skewed rendition of history. It was a show of force, a show of might. We wanted Russia to know that we were not to be messed with. So 2 civilian populations were bombed so that we could flex our muscle. But now, fast forward a few years, 1947, the Joint Commission on Atomic Energy was formed. This was a special commission of 9 people. In secret, the Congress was not to be informed, the Senate was not to be informed. This was a parallel government of 9 elite people who were controlling, directing nuclear policy going forward. So we need to put a smiley face on this thing and roll around 1953 comes Dwight D. Eisenhower talking about atoms for peace. Isn't this a wonderful thing? What a powerful thing we've done. Now we have to have something good come out of it, because that something good will be nuclear energy, and then we'll continue to have plenty of bomb material. So in 1953, the Atoms for Peace, and we struck up some 55 treaties with nations around the world and started spreading this technology around the world. But it's all sort of a nuclear priesthood, a highly, we'd let you know, but you couldn't quite understand it, so let's just leave it to the experts, and we've got to keep it secret a little bit. And so this is the mentality of, okay, we've got this communist menace, we've got to be able to face that. So, we might have to make a few sacrifices. We might have to do a few experiments and see what's going on. So I'm going to ask, Tony, could you bring up that video clip? And this story just broke this week by a sociologist. So, probably somebody who read all of Max Weber's, who I did through osmosis. So we're going to see a 2-minute clip.
The story has taken on a life of its own, and it involves an I-team report into the Army's secret Cold War experiments on St. Louisans.
Right now, a local sociologist is unveiling new research showing thousands of people in the St. Louis area were unknowingly exposed to chemical testing. Investigative reporter Lisa Zigman had exclusive details of the report last night, and today we learned more during a symposium at St. Louis Community College Merrimack campus.
Lisa Martina Taylor has uncovered declassified records confirming that the Army was spraying zinc-cadmium sulfide into the air during the 1950s and 60s. Take a look at this jam-packed auditorium. People who watched our report last night crammed into the place to hear more. We showed you how the Army sprayed the chemical on unsuspecting low-income communities and lied to city leaders by saying they were testing a smokescreen in case of an attack by the Soviet Union. We linked Martino Taylor's research and all the unclassified government documents, and the story has been #1 on KSDK.com ever since. It is now gaining national interest and scrutiny, with some who claim to be in the scientific community saying her research is flawed. Even if this chemical is harmless, thousands of St. Louisans were used as human guinea pigs. The Army never apologized. Most importantly, there are still secret documents about an unknown fluorescent additive that was also sprayed here.
There's a lot of evidence that indicates that people in St. Louis and the city, particularly minority communities, were subjected to military tests that was connected to a larger radiological weapons development and testing project.
Again, the Army insists its chemical spraying in the 50s and 60s was harmless. In the meantime, Lisa's phone line and inbox has lit up today. People remember the spraying, and they want to know if it is any way linked to cancer or COPD that has affected them and their family. We're continuing to press the Army, the CDC, and politicians for more information.